My name is Christine Miller. I'm a student at the California Intercontinental University, and today we're speaking on regression analysis as well as doing an annotated bibliography of three of the articles in this course. Our agenda is we'll be looking at the sample that was tested. We'll look on what a regression test is. We'll look at an analysis of three tests. Then we'll look on the takeaways from those tests. And then we'll look on the annotated bibliography and also the takeaways from the bibliography. And then we'll field questions. The sample was taken from Midwestern region of USA, and the questions related to the level of savings, portfolio valuation, the income level, and the level of debt. The regression test is a method of predicting how one variable will react given the value of another variable. The analysis is used to determine the regression equation, which is y is equal to beta times x plus c. The slope of the line is determined by beta. If beta is not equal to 0, then a significant regression is found. Also, if p is less than 0.05, then the null is rejected. In our first test, we look on determining whether debt can be predicted from income. The null hypothesis is that the regression coefficient beta is 0, and the alternative is that the regression coefficient beta is non-zero. For this test, no significant regression was found. Beta is equal to minus 0.05, the r squared was 0.00, and the p-value is 0.535. Therefore, since p is greater than 0.05, then null hypothesis has to be accepted. In this test, we found that the null hypothesis would have to be accepted. Therefore, we cannot predict an individual's level of debt based on their level of income. The next test was used to determine whether savings could be determined from the level of income. The null hypothesis, again, is that the regression coefficient is 0, while the alternative is that the coefficient is non-zero. This test showed that the p-value was equal to 0.000, which meant that the null hypothesis had to be rejected since it is less than 0.05. The passivity scores, the regression passivity scores, show that APS was equal to 0.91 times the income level plus 0.1. Therefore, APS is predicted to increase as the income level increases. Further, the 95% confidence interval was between 0.09 and 0.11, which does not contain 0, hence lending support to the prediction. As a result of this, the null hypothesis would have to be rejected. Therefore, we can predict an individual's level of savings based on their level of income. The final test was to find out whether the level of savings could be used to determine the value of the stocks or the portfolio value of the stock. The null hypothesis was that the regression coefficient was 0, and the alternative was that the regression coefficient was non-zero. A statistically significant regression emerged. Therefore, the null hypothesis had to be rejected because the p-value was equal to 0.000, which was less than 0.05. The regression passivity scores showed that the APS was equal to 0.28 times the stock level, or the savings level, plus 0.16. As a result, APS is predicted to increase as the savings level increases. Further, the 95% confidence interval was between 0.07 and 0.25, which does not contain zero, hence lending support to the prediction. So for this test, the null hypothesis would have to be rejected. Therefore, we can predict an individual's portfolio value based on their level of savings. Our important takeaway for the regression analysis is that software such as CSPT is used by researchers for ease of analyzing statistics. When alpha is set at 0.05, a significant regression is found to exist if p is less than 0.05. Confirmation rule or injecting the null is that 0 is not within the 95% confidence interval. The regression equation is y is equal to beta times x plus c. If beta is significantly different from 0, then the aggressor x is significant. Savings can be predicted based on an individual's level of income given the data that we use in the analysis, and also that the portfolio value can be predicted based on the level of savings. Onto our annotated bibliography. The first article is a Minitab blog entitled Regression Analysis. How do I interpret R-squared and assess the goodness of fits? This article is focused on regression analysis. It is aimed at taking the reader through the process of understanding how to interpret the results after the regression test has been performed. Graphical demonstrations are also given to aid in the explanation of the theory. The implications and interpretations of both low and high level R-squared values are also given to complete the assessment. The article also includes easy links to other articles that could help to further explain some topics. The second one is the chi-square test of independence, which was written by Mary L. McHugh. The article is focused on chi-square and its relevance to researchers as an analytical tool. It's aimed at making the reader understand the relevance of the test and how it should be calculated. This is further explained by the use of a case study, which moved from the formulation of the hypothesis to the results of the chi-square test and what the interpretation of the results meant for the researcher. Kramer's V is also explained in the article, which showed this link to the chi-square as it tells how strong the relationship is between the variables. The third and final annotated bibliography is on correlation, which is written by William N.K. Chokin. This article is focused on correlation and its usefulness in research. To explain this relevance, Chokin used an example and worked through the calculations and results using diagrams where appropriate to explain it. He also showed the application and relevance of the hypothesis test and how to interpret the results of the test. The takeaways from the annotated bibliography are that it's been a number of years since I have done a research course, and I found these articles beneficial as they help to remind me of some of the principles as well as teach me new ones. Also, the importance of these articles was based in their simplicity and their basic explanations. The use of examples in two of the articles allowed me to garner a better understanding of the topics. I was able to work through them along with the author. Finally, through these topics, I was able to learn the following. 1. How to conduct a correlation test. 2. The relevance of the correlation test. 3. The importance of the chi-square and Kramer's V to researchers. And 4. The interpretation of a regression analysis. Thank you for listening to this presentation today, and I will field any questions.